In this section, we're going to learn how to classify enthalpy changes that happen during changes in states of matter. Okay, so remember, an endothermic reaction is a process in which energy is absorbed. An exothermic reaction is a process in which energy is released. Now notice it says process. It's not necessarily, it doesn't have to be a chemical reaction. It can be a physical process as well, like changing from solid to liquid, or liquid to gas, or gas to liquid. Okay, so let's look at a heating curve here. So heating curves look like this. Remember, the states of matter are always on the slanted parts of the line. We have the solid, then the liquid, then the gas. And if the question's asking about the transition going from a solid to a liquid, or a liquid to a gas, is that an endothermic or an exothermic process? Well, if you know the definition, an endothermic process is one in which energy is absorbed. So, of course, it takes energy to be absorbed into the solid to start increasing the motion, the kinetic energy of those particles until they start melting into a liquid. And then the liquids need to absorb energy to boil into a gas. So anything going uphill is an endothermic or an energy absorbing process. Okay, so the reverse must also be true. Going downhill from gas to liquid or liquid to solid, that means you must remove energy. Gases have more energy than liquids, so I need to take energy away from the higher energy gas to transition down the hill into a lower energy liquid. And liquids, of course, have more energy than solids, so I need to remove energy from the liquid and slow them down to freeze them into a solid. So any energy removing process is an exothermic reaction or exothermic process. So going down heating curves are always exothermic processes. Okay, so let's look at an example question. This is a very simplified version of a Regents question like this. It says, which choice below describes an endothermic process? Now, on a Regents question, they might give you names of specific chemicals, but it doesn't matter what those chemicals are. The states of matter are what's important. So choice one is liquid to solid, then gas to liquid, gas to solid, or solid to liquid. So a good tip for this type of question is to sketch a potential energy diagram, a heating curve. And ask yourself which one of these transitions would be an endothermic process. Of course, an endothermic process is an energy absorbing process. Okay, so here's our heating curve sketched out. So let's look at our choices. Liquid to solid. Do I need to absorb energy or release energy to go from liquid to solid? Well, I'm going downhill. Liquids have more energy than solids. So therefore, this is an exothermic process. I need to release energy to freeze it, not absorb energy. Choice two, gas to liquid. Same thing, we're going downhill. Gases have more energy, so I need to release that energy, give off that energy to the surroundings to condense it into a lower energy liquid. Choice three is gas to solid, so that's still downhill. Gases have more energy than solids, so I need to remove a lot of energy to condense it and then even more energy to freeze it. So our answer must be choice four, solid to liquid. I need to absorb energy into the solid to melt the solid into a liquid. So our answer is choice four. So in summary here, when answering questions about enthalpy during changes in states of matter, it's often helpful to sketch out a heating curve. Remember, an endothermic process is one in which absorbs energy, and absorbing energy is always going up the curve. An exothermic process is one that releases energy, so releasing energy is always going down the curve. And if you don't remember any of that, you can look at your four choices in the question and pick the one that's not like the others. So let's go back and look just for a second here at our curve, at our question. So liquid to solid is downhill. Gas to liquid is downhill. Gas to solid is downhill. Solid to liquid is uphill. Many times in chemistry, if you come to a question and you have one choice that's not like the others, chances are that's probably the answer. So that's how you answer that type of question, and we'll practice more of these in class. But if you have any questions, please let me know.